Hi, my name is Samara Wallace, and when I saw I had this project, I thought, what would be something cool that I could show? Then I thought, well, my mom teaches first grade, and she does lots of science experiments that have a visual aspect to it, and one of my favorites is chromatography. She does a color chromatography experiment. So I thought, well, first I'll show you the experiment, and then I'll explain what chromatography is. So first, for the experiment, I have 3 coffee filters. This one has red and green and green. This one is blue and purple. And this one is red and blue. So first what we're going to do is these, and we're going to sit them in the water. And then we'll be back in a couple of minutes to see what they look like. So, I have now taken the coffee filters out of the water, but before I show them to you, I'm going to tell you what chromatography is. So chromatography is the separation of a mixture by passing a solution, suspension, or vapor through a medium where the parts move at different rates. This normally separates them. So in this experiment, I'll show them to you. This is the red and blue one. This is the blue and purple. And this is the green and orangey color. So what happened was with these ones, see how the top is yellow and the bottom is red, and the top of this one is blue? It's because the colors have different polarities. The less polarity a color has, the less it bonds to the paper, which means the less it bonds, the higher up it moves. So in this instance, we have green and the orange. The yellow is less polar than the red, so as the red goes up, the yellow keeps going where the red stops. Same with this one. See, the very tip is blue, and it's because the blue is less polar than the green part. So as the green bled up, the green stopped bleeding and the blue kept going. This one you can really tell. The purple, all right here, the blue kept going where the purple stopped. Now the reason the red and blue by itself didn't really change color any is because they are primary colors. They're not made up of multiple colors, so they don't have any colors to separate. As you can see, I had to come inside because the bugs were getting too loud, but that's okay. Now that I've shown you what chromatography looks like, I can tell you all about it. There are 4 main types, and the first type we're going to talk about is paper. Paper chromatography is what we used in the experiment. So paper chromatography, they apply the solution to a piece of filter paper that already has a solvent on it. And then they take that paper and they put the corner of it closest to the spot of solution into a solvent of a different kind, one that the chemicals in the solution are soluble at different amounts. And then when they put the paper in there, as the solvent spreads up the piece of paper and through the solution, it spreads out on the paper like we saw with the coffee filters. This makes it a lot of times they apply reagents to it so that it's colored, and then they can see what chemicals spread out to where and how they react with the solvent they put in it, and if there are certain chemicals in a solution. Paper chromatography isn't used very much today anymore. Now people use it a lot as a teaching method, because now instead of using paper chromatography, people use thin layer chromatography. Thin layer chromatography measures non-volatile mixtures. First, you take a glass, plastic, or aluminum foil sheet and coat it with a thin layer of an absorbent material. Then you apply the sample to that, and then you take that sheet and you stick it into a solvent, and just like with paper chromatography, it absorbs up the paper, and because they all move at different rates up the paper, you can tell what things are there and what aren't there, and which ones do what in the solvent that you dipped it in. There are a bunch of different uses. They can, a lot of times, thin layer chromatography is used to check the purity of something. It's used in cosmetics, it's used in food sweetening agents, and it's used in preservatives. The next type of chromatography is gas chromatography. Gas chromatography analyzes a compound that can be vaporized without decomposing. They take a sample and insert it into the chromatograph with a syringe. It is then heated up and turned into a gas if it's not already a gas. This gas meets with whatever chemical they put into the body of the chromatograph. They put that chemical there to help detect what's in the sample. This is called the station phase. It is then heated again, and as they mix, the sample separates and exits out the column. At the top of the column, they have some sort of detector to detect whatever they're trying to find out is in the sample. Lots of airports use gas chromatography to find bombs, and it's used a lot in forensics with fibers and blood that's left at crime scenes to see if they can connect it with any other sort of chemical that the criminal might have used, or a criminal's genetic information. The next type of chromatography we're going to talk about is liquid. Liquid chromatography happens on a column or a plane. They take a sample, and the sample is the mobile liquid. It passes through a column or plane. The column or plane is filled entirely with a stationary phase. The stationary phase is made up of irregular particles or spherical particles. Due to the differences in the sample, the different solutes will interact with the stationary phase differently, and as they do, that's when you're able to detect what's in it, what's not in it, and how much of what's in it is in it. Liquid chromatography is used in water purification and in detecting impurities in the pharmaceutical industry. It is also used to detect proteins and nucleic acids. In summary, chromatography is the separation of a mixture by passing a solution, suspension, or vapor through a medium where the parts move at different rates. There are 4 types of chromatography: gas, liquid, paper, and thin layer. Paper and thin layer are very similar. Paper, you put a sample on the bottom of a piece of paper, on the bottom of filter paper, and the water transfers it through the filter paper, and that's how you detect the particles that are in it. Thin layer is done the same way, but instead of filter paper, you use a piece of glass, plastic, or aluminum, and a very absorbent material. I hope you learned something and enjoyed watching this video.